Okay जी, can you hear me? आवाज आ रही है जी? Okay जी, so where were we? We were actually trying to figure it out what is the average value of the output, right? So to figure it out, the average value of the output, so what we can see that from 0 to pi, we have the positive half cycle. So what we are going to do, so we are going to integrate from 0 to pi for the positive half cycle, and the total duration is 2 pi. So this means we are going to divide it by the total duration, which is 2 pi, right? Are you with me? आवाज आ रही है जी? Can you hear me?
Sir.
जी आवाज आ रही है जी?
Yes, sir.
Okay जी. So to figure it out, the average value, what we can do, we can integrate from 0 to pi for the positive half cycle, and then divided by the total duration of the cycle, which is 2 pi. So when we do that, what we are going to get, if you see, we will have the integration of because Vm is a constant quantity, so we can take it out, Vm divided by 2 pi. And what is the integral of sine theta? Anyone? Integral of sine theta? So if you integrate sine theta, this is minus cos of theta, and the limits are from 0 to pi, right? Now, what will happen that if we put the values, we will have V average is equal to minus Vm divided by 2 pi. And what is cos of pi? Cos of pi is minus 1. And then the minus cos of 0. Cos of 0 is also 1, right? We have this value. So this means we can have minus Vm divided by 2 pi minus 1. So this means it is minus 2, right? And then negative and negative, minus Vm into minus 2. So this means it is 2Vm divided by 2 pi. So this means we have V average is equal to Vm divided by pi, right? So if you see, if we go on to the curve, the average value will be something like this, right? Which is Vm divided by pi, right? Any question? Anyone having any question? कोई question तो नहीं है जी? Can you hear me?
Yes, sir.
Yes, sir.
Okay जी. So this is the situation when we have considered the diode as an ideal diode. Now, what if we consider the diode as a practical diode, right? Or a simplified equivalent diode. So in that specific case, what is going to be the situation? Now let's see. Now, if we consider the diode as a practical diode, right? So practical diode means we will be having a drop across the diode that will be equal to, if it is made up of silicon, it will be equal to 0.7, right? So whenever we have the positive half cycle, right? So what is going to be the output when we are applying the input Vi, right? So let's see what is going to be the situation that we can, whenever we have the positive half cycle, so this means this side of the AC source is positive, this side of the AC source is negative. And when this is the situation, so what we can do that we will have only the forward bias unless and until the potential across the diode is equal to 0.7 volts, right? If the diode is made up of silicon. So this means the once the input is going to overcome 0.7 volts, then the diode is going to start conducting, or this means the diode will become forward bias, right? So what we can say that after 0.7 volts, so this means we have a DC source which is 0.7 volts. Once this is there for the positive half cycle, then the switch will be closed, right? And then we will have the output that will be across R, right? Are you with me? बात समझ में आ रही है?
जी सर.
So once the diode is going to have a potential of 0.7 volts, so this means we have overcome the barrier potential, then the switch is going to be closed. When the switch is going to be closed, so then what is going to be the situation for the output now, right? So this means the peak value or here previously which was Vm, so now it is Vm minus 0.7 volts. Are you with me? Right? Because if you see the input is something like this, so this value is Vm. But now there is a drop of 0.7 volt across the diode. So the peak value cannot be at the output, it cannot be Vm, but it will be Vm minus 0.7 volts, right? ठीक है जी? Are you with me? Question? Question? No question? Are you getting it? You are not getting it? जी. Anyone? आवाज आ रही है जी?
Yes, sir.
Okay जी. So this means the output will be Vm minus 0.7 volts, right? So now as you can see that again previously in the ideal case, what we have seen that for the negative half cycle, what will happen? That again for the negative half cycle, the diode will be behaving as an open switch and the output will be a flat output, right? So again, when the positive half cycle comes, we have the value something like this, and then we have the flat output, right? Now again, if we want to see what is going to be the average value, so now the average will be Vm minus 0.7 volts divided by pi, right? So this is the only difference which we are going to have in the average value, right? So this is the situation when we have this. And there is another term which comes over here, is called peak reverse value or peak inverse value. PIV or PRV. Now this comes with the data sheet. Okay, data sheet जो होती है, do you know what is data sheet? Or it is also called the specification. Specification or in the data sheet. This is the value which actually indicates that how much the diode can sustain in the reverse direction, right? Whenever the diode is a reverse bias, so what should be the value that the peak inverse value should be there so that it can withstand the reverse voltage, right? Because if you see, whenever we have the reverse biasing, so as you can see, we have the AC source. Whenever this is the saturation, so the diode will be reverse bias, right? When the diode is reverse bias, so the reverse voltage which is going to be across the diode, which is normally called peak inverse voltage, and at that time the diode will be behaving as an open switch. So what should this value be equal to? Because the diode, actual behavior of the diode in the reverse direction is, it will be behaving as an open switch, right? So as this is negative, this is positive. So the peak value in the negative direction is again Vm, right? Okay, the peak value in the negative direction again Vm. So this means when no current is flowing because the diode is open bias, so the peak inverse voltage or peak reverse voltage should be greater than this value which is being applied by the AC source, so that the diode should not go into the reverse breakdown region. Because if the ordinary diode goes into the reverse breakdown region, it will go into the diode will become damaged, and once it is damaged, it won't be actually working anymore. So to avoid that, the peak inverse voltage should be actually greater than the maximum value which is being applied in the reverse direction. So this means peak inverse voltage should be greater or equal to Vm. Are you with me? बात
Yes,
समझ
sir.
में आ रही है जी?
Yes, sir.
ठीक है जी? Okay. So with this is the half wave rectification. What if we want to have the full wave rectification? So for the full wave rectification, we have basically two types of rectifiers. One is called the bridge rectifier. The other one is called the center tap rectifier. Let's take a look of both of them. So full wave rectification, right? Full wave rectification. In full wave rectification, the first one is the bridge rectifier. In the bridge rectifier, what we have basically diodes that are connected in a form of a bridge. And how the diodes are connected, let's take a look. That we have one diode, then there is another diode, and then we have the third diode, and then we have the fourth. So what we have B1, B2, B1, B2, B3, and B4, right? Now, what we do that we connect with these two terminals, we connect the AC source, right? And over here we have the resistance R. And across this resistance, we will be taking the output V0 plus noise. And this is our Vi, which is being applied to this circuit. Now, how this circuit is going to behave? Anyone? How this circuit is going to behave? And let's consider the diode as an ideal diode. J. Now we have Vi. Again, Vi is the same. Vi is equal to Vm sine of theta, right? So this means we have a sinusoidal signal, and the sinusoidal signal is again considered diode as an ideal diode. So how these diodes are going to behave? So let's see that when the positive cycle comes, right? When the positive cycle comes, so this means this end is positive, this end is positive, this end is negative, right? So this means the positive end, this means diode D1 will become short circuit, right? Or diode D1 will behave as and closed switch. When this will behave as a closed switch, so this means the current will be flowing from here to here, and then this D3 will be behaving as an open switch, and D4 is also behaving as an open switch. So due to that, what happens? The current flows from the resistor in this direction, and then D2 will be behaving as a short circuit switch. So this, and in this way, we have the flow of current that flows through the two diodes D1 and D2. Are you with me? ठीक है जी? Question? Fine? No? Yes? आवाज आ रही है जी?
सर ये रिपीट कर दें दोबारा जो भी आपने बताया।
अच्छा जी. Okay, so what is happening over here? That we have the sinusoidal signal that is being applied to the bridge rectifier circuit, and with that, what happens that when the positive cycle comes, the D1 and D2 will be behaving as a short circuit switch, or they will be behaving as a closed switch. So due to that, and D3 and D4, they will be behaving as open switch. So due to that, the direction of current, you can see the direction of current is like this, right? Like this. Okay, ji? Now, this is for the positive half cycle. So the output will be taken across R resistance, and the direction of the current is from positive to negative across R, right? So the output will be taken over here in between these two terminals. And once it is being taken over here, so what we will see that the output V naught for the positive half cycle, it will be something like this, right? Now, when the negative half cycle comes, so when the negative half cycle comes, this means this end is now negative, this end is now positive. Are you with me? Okay, ji? When this is the situation, so what we say, that, and this is the situation. So now D3 will become as a closed switch, and D4 will be behaving as a closed switch. But now D2 and D1, they will be behaving as the open switch. So the direction of flow of current will be from D3 to through R resistance, and through R resistance, it goes from T4 and in this direction, right? In this direction. So again, if you see the direction of flow of current through the resistor R is the same as for the positive half cycle, right? So due to that, what happens that due to the negative half cycle, the output will again have a positive half cycle like this. Are you with me? बात समझ में आ रही है?
Yes, sir. Yes, sir.
Because the flow of current through the output resistor R is in the same direction as for the positive half cycle as well as for the negative half cycle, right? So due to that, again when the positive half cycle comes, we again going to get a positive half cycle, and when the negative half cycle comes, again we are going to get a positive half cycle at the end, right? Now, so if we want to find the average value in case of a full wave rectifier circuit, so what is going to be the average value? So if you see the average value over here will be, because if you see we have from 0 to pi, we have the positive half cycle, right? But the duration of this is from 0 to pi as well. So this means again we will have 0 to pi, and the area under the curve is also the pi, right? So what we will see, Vm sine of theta b theta, right? And when we do our mathematics, so what we are going to get, we will have V average is equal to 2 Vm by pi, right? ठीक है जी? Question?
No, sir.
Okay. And again, if we consider the diode as the practical diode, right? If we consider the diode as a practical diode, so what will happen? That as you can see, that in the positive cycle as well as in the negative cycle, the two diodes, they are having a drop of 0.7 volts, right? So this means the peak value in case of the practical diode, it will be Vm minus 1.4 volts. Okay, ji? In case of silicon. Are you with me?
0.7.
Vm minus 1.4 volts. Reason why I'm saying this. Reason is that whenever you have a positive cycle or a negative cycle, in both the cycles, there are two diodes which are having a drop of 0.7 volts. So 0.7 plus 0.7 is 1.4 volts, right? So the peak value at the output will have a value which is having a difference of two barrier potentials. So two barrier potential is equal to 1.4 volts in case of silicon, right? So due to that reason, what happens that the peak value of the output will be Vm minus 1.4 volts, right? And similarly, the average value over here, in case of the practical diode, it will be V average will be 2 Vm or what we can say it is, or we can say 2 by pi Vm minus 1.4, right? Okay, ji. Right? So this is the situation. And what about the peak inverse voltage or peak reverse voltage in case of the bridge rectifier? So if you see in case of bridge rectifier, what we have, we have basically, if you see in one loop, we have this diode, which is, we say we have B1, we have this, and we have this, right? So whenever we have the positive half cycle, D1 is forward bias and D4 is reverse bias, right? So in that specific case, what is happening over here, that D1 will be behaving as a short circuit, right? So D1 is behaving as a short circuit. This means the switch is closed over here. And D4 is behaving as an open switch. So when D4 is behaving as an open switch, so across R, we have a maximum value of Vm. So this means that the diode D4 peak inverse voltage should be actually greater than or equal to Vm, so that it can withstand the reverse voltage of Vm, or if it goes beyond, so it can actually sustain the reverse voltage in the opposite direction, so that whenever we are operating the diode in the forward direction, the diode should not be damaged. Are you with me? Question?
Yes, sir. No,
Question?
sir.
Okay.
No, sir.
Okay, there is another type of full wave rectifier circuit that is called center tapped rectifier circuit. Center tap rectifier for full wave rectification. Now, how this circuit behaves, that what we have a transformer, right? You have studied the transformer. A transformer is having one secondary winding and one primary winding. So depending upon, there is a primary winding and then there is the secondary winding. And what we say the turn ratio between the primary and the secondary is 1:1. Okay, and what we are doing, we are applying the sinusoidal signal to the primary winding of the transformer, right? And again, the signal is the same signal. And at the secondary, what we have done, we have two diodes that are being connected in such a fashion that the resistance is being connected to the center tap. So if we have 1:2, so this means whatever the input signal we are applying over here, so the same signal is going to be transformed to the secondary with a magnitude equal to twice the magnitude of the primary. So if we say the input is something like this, so at the secondary we have the same signal over here in the size which is equal to something like this, right? Are you with me? So this means the secondary is having twice that of the primary. As we have done the center tapping, so due to that, we are dividing the output, the secondary side into two. The portion over here is again equal to the primary side, and the portion over here is again equal to the primary side. So whenever the positive half cycle comes, so this means we have this side is positive, this side is negative, this side is positive, this side is negative, right? So when the positive cycle comes, what we say that D1, D2, and across the resistor R, we are taking the output over here, which is V0, right? We are taking the output across the resistor R. So when the positive half cycle comes, so in the secondary, we also have the positive half cycle. And due to this positive half cycle, D1 becomes a closed switch, but D2 at the same time behaving as an open switch, right? So due to that, what happens that at the output, what we have, okay, the session is going to end in less than a minute. So we will continue after 5 minutes as the session is going to end. Okay, ji? We will restart from here.